have to use this one, right? And those things will help. Yes, 1, 2, 3. 1, 2, 3. Yeah. Turn on that. Low 1 2 3 low test 1 2 3. What is 1 2 3 1 3. Low test 1 2 3. Low test 1 2 3. Low 1 2 3. Low test 1 2 3. Low 1 2 3. Low test. Low 1 2 3. Low 1 2 3. Okay. Good morning, everybody. Welcome you to SCI33205, and we are live at this is for M604, right? We are live at the 4th chapter, and what else? What should I do? We have recorded, right? In everything, right? This one, right? You should also attend class. Zoom, Zoom. You have to go to the Zoom. This one. And how to do that? Get to the Zoom and see what happened. Zoom, and one to continue Zoom meeting button. Oh no. Yeah, here account. Yeah, account Steve video. Yes, that's about. Alright yeah ขอพาวิทย์อยู่ที่YouTube นะครับขอพาวิทย์Pavit is there. Okay. I hope that everything is alright. And only 2 people have written their names. And what else? Nothing more, right? So we go ahead with this. But we just have a new version, right, of the lecture because I improved something. Two zero 5 and yeah, this one or open a new thing, new important from the cloud drive. In yeah, this one is possible. Okay, this is for yeah, this is M604&M605, 2021, right there. Yes. Okay. Here we start our lecture. How it is there, right? Let me capture all the stuff. Okay, and this one on mobile ขอเจอหน่อยนะครับที่ YouTube อีกอันหนึ่งไม่มีใครนะครับ alright yeah here I hope the sound is alright. Oh, I need to monitor most of you, right? Use the white one. Yeah, this one, the right one. Okay. I hope that เข้าใจว่าทุกคนจะได้ยินเสียงผมนะครับ if not then let me know ไม่ทัศน์นะครับเดี๋ยวนะครับส่งไฟล์ให้คุณลี่นิดนึงครับเขาจะเอาเป็น Word ครับคุณเชอรี่นะครับเลขาของ E+ เขานะครับ Okay. All right. I hope that everything is fine. ชัยสิทธิ์นะครับชัยสิทธิ์ก็พิมพ์ชื่อกันมานะครับมีพิมพ์อัครวัตรแค่นี้นะแต่เข้ามารอที่ตรงนั้นก็เยอะอยู่นะครับที่YouTube นะครับมีปะภาวิทย์นะครับมีธนนัทนะครับ and now who else yeah someone more nothing more right no one okay I hope that everything is fine okay กสิริส่งรูปมานะครับ okay all right here we have talked already oh no this is M604 yeah the bigger scale for the เดี๋ยวผมเช็คซาวด์นิดนึงครับเสียงมาไหมเอ่ยเสียงไม่มาครับมาเลยครับ okay all right yeah here นัทพัฒน์นะครับ all right the sound the audio is all right right โอ้ผมเข้าอีกเครื่องแต่ผมต้องปิดเสียงนี้ใช่ไหมเครื่องนี้ oh no sorry for that all right นะครับหวังว่าเสียงใช้ได้นะครับเสียงใช้ได้ไหมครับเสียงใช้ได้นะเช็คที่ตรงนี้แล้วกันครับthe white one I have to connect the black one to the right that one so there and the right okay it seems that the audio is fine okayที่YouTube เสียงใช้ได้ไหมครับ YouTube ครับพวกสุภสินธนนัทเพทรานะครับแล้วก็กสิรินะครับเสียงที่ YouTube ออกไหมเอ่ยที่ซูมเสียงออกไหมครับคราวที่แล้วเสียงไม่เข้านะครับก็ไม่มีใครบอกผมนะครับ I hope that everything is fine yeah the capital calorie is the bigger version for the same thing which is the unit of the calorie right yeah so we have to talk a little bit about the unit but it's quite rare okay except that you pick up the problem from any book in chemistry yeah the capital calorie is the 1000 higher version of the small calorie here okay it's instead of 4.186 it's equal to 4000 okay 4000 and 186 all right and yeah we will it's quite rare for us in physics that we will face with or we encounter this the scale of the heat okay all right yeah Internal energy refers to the total energy of all the molecules within the object. Yeah, it's quite important for the succeeding for the next section, that we will have to consider the internal energy too, right? Temperature is related. Now we arrive at the next quantity, which is temperature. All right. How could we say? Temperature is like the height, okay, of your body, and heat is like the weight of your body, and temperature is related to the kind of the molecules of the material. It is the average kinetic energy of individual molecules. Temperature is commonly associated with how hot and how cold an object feels when we touch it. And an object that feels hot usually has a higher temperature than when it feels cold. In a device of more familiar type that is used to measure the temperature is thermometer, right? Then we are gonna talk about it quite often in this chapter. But nowadays there is no only thermometer. There is also other type of device, and that's the if you have smartphone and if you download an application that has a functionality of scanning or telling you how hot of any object is, so that's a great thing, right? And then yeah, you can use also your smartphone nowadays, okay, to scan any object if you want to observe or you want to see any temperature, the temperature of anything, right? Especially here in the pandemic era and pandemic situation. All right, right there. Okay, now, okay, it's not like my generation thermometer is only the single device that we could find at my era. Okay, while I was like you in 15 years old or 16 years old or 18 years old, something like that. In that era, it was only the one device, a single device that can be used to measure the thermometer, especially when we are at the hospital. Okay, when we don't use it every day. But in some other countries, for example, in the country that has a really cold weather, they usually have the thermometer at home, okay, in order to observe the weather. Okay, they would make a decision wear the jacket or not when they want to go outside, out of the building or any residence. Okay, yeah, thermometer can be seen here in figure number 1. All right. Yeah. It consists of the glass, right? And we leave the mercury. Okay, usually we use the mercury, or some in some thermometers they use the ethanol, okay, which is a kind of alcohol. Yeah. When system becomes hotter, the liquid inside, okay, whether it's mercury or ethanol, we are gonna have the expansion of the liquid inside. Okay, so when we get hot, when we get more heat, okay, and the expansion or the rising level of that liquid is going to be higher. Okay, ขออนุญาตเช็คซาวด์ตรงนี้นะครับว่าซูมเสียงไปหรือเปล่านะครับคุณอยู่กันหลายคนนะครับก็ไม่ได้แจ้งผมนะว่า sound ออกหรือเปล่าครับเสียงโอเคเสียงออกอยู่แต่ว่าทำไมไม่รู้ว่าซูมทำไมไม่มีเสียงครับ alright ที่ซูมนะครับซูมมีเสียงนะโอเคนะครับเช็คแล้วนะครับokay yeah, when the liquid expand we will get the rising level of the mercury or ethanol, right? And the value of air increases. Okay, and we use this scale to measure the temperature of anything. Right? All right, so we have the thick area, okay, of the glass in this case because we want the strength, okay, to hold the piece of this thermometer, and heat from anything, okay, that we want to measure get into the liquid as soon as possible, okay, because if the glass is thicker, so we have to wait for a long time, okay, when we plug the thermometer into our body, so we have to wait for a long time. But if we have thinner area for this part, we're gonna get quick results, okay, in measuring any system temperature, okay. Yeah, the next thing is the thermometer in the normal scale, right? You may have ever seen this in I don't know, in Matheum 3 or something like that. You know that if you bring the ice, okay, you leave the ice into this one, you get you will get 0 degree of Celsius, right? If you leave the ice, because if there is no heat at all, and the heat out this area, you will get 0 degree, okay, out of the thermometer. All right, and yeah, that's the basic size you have met in Matheum 3 or something like that. And if we put the heat, okay, from the fire, and we boil it in until it reaches a situation when we have when there is steam or vapor here, and what we could observe from the thermometer is that the temperature here on the thermometer will be at 100 degree of Celsius, right? And yeah, that's the freezing point, okay, and here is boiling point, okay. That's the basic scale, okay, we use to define the scale of the temperature, okay. We use water as the reference, as the freezing point, and the boiling point, okay, the situation when we get vapor or steam. All right, yeah. Temperature can be measured in several way, okay. Liquid volume of liquid, okay, that's what you get from the conventional thermometer, right? And okay, and you put the heat into this metal bar, for example, and you can observe that this metal gets more length, okay. It will provide more length to you, so it is stretched, and yeah, the length of any solid can be used as the indicator to measure the temperature. The next one is that you keep the volume of the gas to be constant, okay. You keep the gas volume constant, and then if you put put the heat into that, you can get higher temperature by observing the pressure of the gas. All right, and yeah, the internet here is not quite stable. We're gonna use this one, okay, FB. Yeah. The next thing is we keep the pressure of the gas constant, okay, and we let it be constant, and we can observe the increasing volume of the gas. Okay, only one quantity you can keep it to keep it constant, and then you can observe another one, okay, pressure and volume. And in electrical system, we can also observe the heat or the increasing temperature from the electric resistance of the conductor. Okay, if you let the heat pass on to any conductor, and you can observe the increasing resistance from that conductor. Okay, we also use this one in many applications. For example, you use this one in the, I don't know, is what is that? Is the radiator in the car. Okay, you know the radiator. ภาษาไทยเรียกว่าหม้อน้ำนะครับโอเคไหม in the radiator in the of the car, okay, we have a sensor, okay, that touch the water that flow around the engine, right? And that sensor use this technique, okay, when the water from around, when the water flown from then yeah, we could let the current flow, and we can observe the temperature from that property. Another way is that if you look at the fire directly by eyes, you can classify the temperature by observing the color of that fire, okay, or any object. Okay, temperature is the measure of hotness or coldness of on some scale, but what scale we are gonna use, okay? Of course, you may have ever seen the temperature unit in degree of Celsius, okay? That's the most familiar with. That's the most familiar unit that we have seen when we are in Thailand. But if you have ever been in the United States or even in the British, in the Great Britain, they also use a different temperature unit. Okay, the most familiar one is centigrade. Okay, centigrade seems to be an ancient word. All right, it's not the modern word, and yeah, we use it for long time, even while I was a child. Okay, secondary school. Okay, and I was a person who is chosen by the school to get into the competition in science and so on, a science problem. So yeah, I still was taught to memorize the unit of the temperature by using the words centigrade. Okay, and nowadays the people used doesn't often hear these words, the centigrade one. Okay, we rather use the surname of this person. Okay, his name is under Celsius. Okay, or simply speaking, Celsius. Okay, yeah, the Celsius scale is derived from the water property, right, at the freezing point of 0 degree and at the boiling point of 100 degree of Celsius. Okay, yeah. C can stand for centigrade. Okay, why I was shy, and Celsius is also the C version of the unit, right? But it's but it comes from the surname of this person, under Celsius. Okay, and for a substance colder than freezing water is a negative number in degree of Celsius, right? Yeah. If you have anything like dry ice and so on, okay, it's on the order of minus blah blah blah, right, of degree of Celsius, because it's very very cold, right? And yeah, if you have ever been in any area in Russia, okay, in their winter they would have something really less than 0 degree. Okay, sometimes in Siberia they have minus 50 degrees of Celsius, right? And if you want to keep the meat, okay, you just leave it outside the home, okay, and the quality of the meat is gonna be kept well. Okay, you don't need to buy refrigerator at all. And like I was in Germany, okay, I have done the doctoral degree, the PhD. It's not PhD, okay, it's known in doctoral degree in Germany. While we were in winter, the temperature is less than 0 degree. There was snow, and we just left the bottles of beers outside the water, the windows. Okay, and that's what really happens when you live in a country that is really really cold. Okay, yeah, the negative value of on the Celsius degree means something get frozen. Okay, Celsius scale is used both in everyday life and in science. Okay, if you do the laboratory, most of the measurement rely on the Celsius scale, and if you work in a company, in a factory, most of the thing will be measured in Celsius scale. Okay, but there is an exceptional case. For example, in the United States, okay, the USA, and a few other English-speaking countries. I don't know, in New Zealand or in Australia. I have never been there. Okay, and the people often use also the people often do not use the Celsius scale, but rather they use this scale. Okay, this person, Daniel Fahrenheit. Okay, Daniel Fahrenheit is a person who observed something about heat, yeah, and temperature, and he built up his own scale, right? In yeah, it's called according to it's known according to his surname. Fahrenheit scale is still the most frequently used temperature unit in the United States. Okay, if you have a plan to study in the United States, the people use different units. Okay, they use new way to say about the weight, right? In pound, they measure the height of their bodies in feet, right? In feet or something like that. And also one of the thing, the temperature is gonna be measured not in degree of Celsius. Not so often used Fahrenheit scale. All right. Okay. Yeah. The next thing is we will see the comparison between the Celsius scale. Okay, if in modern, if you are the owner of the company that produce the thermometer, okay, you should offer 2 scale, okay, so that you will have more chance to sell your product in different area around the world. Okay, and that increase your opportunity, okay, your benefit, your chance in the market share, and so on, right? Yeah, in some thermometer they provide 2 scale simultaneously. The left one is on the Celsius scale. The right one is shown in Fahrenheit scale. Okay, so let's see the basic property of our substance. Okay, we consider the boiling point and the freezing point of the water, right? The freezing point of the water is, as you know, at 0 degree of Celsius, and it's equivalent to what is that? It's equal to 32 degree of Fahrenheit. Okay, exactly the same. And the boiling point of the water is the steam, when we get steam of the vapor of water, right? At 100 degree of Celsius, and you get 212 Fahrenheit degree of Fahrenheit. And yeah, the room temperature most scientists refer to is at 20 degree of Celsius, right? And yeah, 20 degree of Celsius is not the room temperature in Thailand, because we rarely have the temperature at 20 degrees of Celsius, except that you stay inside the building and you turn on your air conditioner. Okay, but if you get out of the building, it's quite rare, except that we are in winter. Okay, this is, I would say, the room temperature for the North America people or for the European people. Okay, the body temperature is quite standard in every country. So we often use this value in order to classify which person get trouble with pandemic or COVID-19 or not, right? As the situation goes on, you can see the temperature everywhere. You go to the shop, to any store, right? At the entrance, they often provide a thermometer to measure, right? And 37 is the value for the normal or typical, I would say typical body temperature, right? Okay. But it's not the case. Okay, under Celsius and under Fahrenheit, they provide temperature scales for different areas around the world. Okay, but mostly they are related to the water, right? And several situations outside. But when the science has developed quite a lot, and the scientists has found that the degree of Celsius, the Celsius scale of Fahrenheit might not be so convenient in order to analyze some properties of the substance on Earth or even in the space, right? Because they have measured some properties of gas and so on, and they find that another scale would be more appropriate when we when we do the experiment in science, or when we make the measurement of any object temperature in science. So the people has observed, the scientists have observed the gas and the expansion of the gas and the volume of the gas together with the liquid. This liquid is mercury reservoir. Okay, and they measure the temperature and the pressure together, right? Along the x-axis, and they found that when we increase the temperature, make several experiments. Okay, they make several trials, and they found that if they plot the result on the typical graph scale, this line is gonna bring you to the same point. Okay, these three trials, these three experiments, will bring you to the same point, and this point is equal to minus 273.15. Okay, but for you at the high school level and Mathematics 6, it would be sufficient to use only the value minus 273. All right, yeah, and that would be sufficient. Okay, you don't have to be so precise like me, but in many cases, I often use 273.15. Okay, because I want to be precise. Okay, yeah, they have got several experiments, and all experiments bring us to this point. Okay, minus 273.15, and this will be the lowest temperature of any substance that the scientist has observed. Okay, so how often could we deal with the Kelvin scale? This scale is called Kelvin. Okay, and we would say at this value, we would say it's the absolute temperature value. It's 0 Kelvin. Okay, that's the lowest temperature substance any object could have. Okay, the scientists believe that. Okay, in the space. Okay, there should not be no lower temperature than this. Okay, and the person who observed first is this person. Okay, in 1948, or sorry, in 1848, he know that the molecule stopped moving at absolute zero. Okay, it's called absolute zero temperature, and he proposed an absolute temperature scale. Okay, which is now called Kelvin scale. But his name, why he was born, is not Kelvin. Okay, Kelvin is the length. That is what you may get if you live in England, in Great Britain, in United Kingdom, and you have done a lot of good thing. It's like you are the trainer of a soccer team like Manchester United, but I'm not fan of Manchester title, right? And yeah, William Thomson is the name that he since he was born, and he made something good to the society in England, and he got the rank which is known Baron Kelvin. He was the first person who got this rank, and yeah, the people just used the surname of this position. It's called a Kelvin scale. Okay, but his exact name since he was born is William Thomson. Okay, yeah. Kelvin scale is the temperature scale that is used commonly in science. Okay, it's not the normal temperature when you touch a gun. Capture. When you get into the supermarket or department store, okay, and you want to measure your body in Kelvin scale, okay, no one is gonna realize or understand that, okay, because it's not commonly used in daily life. Okay, but if you work in science, if you are physicist, if you are chemist, okay, and you do the experiment in lab 0 Kelvin at the lowest possible temperatures, so that's why they call absolute zero. Okay, they believe that I'm not scientist. Okay, I don't have deep knowledge inside. They believe that any matter in the space should not have the temperature less than this. Okay, and absolute zero is the temperature at which everything, including air, freezes solid. All right, but I'm not sure. Have you ever seen the air get solid at minus 273 because it's quite hard to have that environment. Okay, the environment with negative 273 degree of Celsius. Okay, even negative 70 to keep the Pfizer vaccine. It is also difficult for us in Thailand to have that moment. Okay, unlike other temperature scales, Kelvin scale is an absolute scale. Okay, you cannot have any other scale that can capture all the details of the matter anymore. Okay, better than this. I'm not sure. Okay, because when the time goes by, someone may propose a new thing. If you fall in love with physics or in science, you may work in university or in any research center, and you may develop your own scale that is more appropriate to what you discover in the laboratory. Okay, and when you pass it away, the people are gonna use your surname as the temperature unit. All right. Yeah. What else? I think there is also another unit scale, right? The temperature unit, which is called Romer, right? But we would not talk about Romer scale. Let me find in the internet. Temperature, right? Have you ever heard the word Romer, right? Romer is the is the Danish name, right? Yeah, it's a kind of temperature scale. Okay, and there is a formula between Romer and Kelvin and Celsius too, right? Yeah, but if you are interested, and you can browse the information by yourself. Okay, but the name is taken from the Danish people. Okay, yeah, this is the experiment. Okay, in order to find to discover how the Kelvin scale emerges, and the constant volume of gas thermometer measure the pressure of the gas contained in the flask immersed in the bath. Okay, yeah, you can see the volume of the gas in the flask is kept constant here, and by raising up or lowering reservoir B, all right, here, to keep the mercury level in the column A constant, right? Yeah, okay, it's called constant volume gas thermometer, like this. Okay, you can even measure the ice. Okay, anything that has really extreme temperature. Okay, yeah, this is what we have already considered. Yeah, this one is also the same thing. Okay, but it's taken from another book. This one is taken from the book number 4. This is from book number 1. Plot of pressure with respect to time. Okay, and yeah, this one is more detailed. You know that the water, it get frozen at 0 degree of Celsius, and you can get higher temperature for the water, and the water cannot be less than this. Okay, minus 273. At this point, okay, everything is gonna be in solid state. Okay, everything will be solid, and that slide show the plots extrapolate to 0 pressure of temperature, but it's measured in Kelvin. We would say this one is 0. Okay, 0 Kelvin. Pressure versus temperature at constant volume of 3 gases. Okay, they used different gases to get these plots. And let's talk about the thing that happened in space in nature. All right. So let's start from the lowest temperature. Okay, lowest temperature is achieved around 10 less to the negative 10. Okay, it's almost zero, right? Almost zero. And yeah, at 1 Kelvin, okay, around something above 1 Kelvin, 2 Kelvin, and so on, the helium get liquid state. The helium gas, okay, gets the liquid state. And if you are at something 11 Kelvin, your hydrogen, okay, hydrogen is a gas, right? But it's gone down to liquid. It's gone down to be liquid around 11 Kelvin. And if we are at 60 or 70 Kelvin, the nitrogen got the liquid state, and the water freezes at what is that? It's 0 degree of Celsius, right? And it's around 273.15, right? Yeah, the water gets frozen, and at the 1000 Kelvin, 1000 is really high, right? It's around 800 or 700 degree of Celsius, something like that, and you get 700 degree of Celsius. The copper is gonna change their phase from solid to be liquid, right? It's get molten, and oh my god, it's around 5000 Kelvin, which is around 5,000 degree of Celsius too. You can reach the skin, the surface of the sun. Okay, but we would not have any aircraft to get there. Okay, because it will be completely destroyed. Okay, let's go somewhere which is quite far from our Earth. Solar corona has a temperature of 1 million Kelvin. Okay, this is what the scientists expect. They could expect from the next million years the human can develop any spacecraft and so on to get there and to measure the temperature. Okay, they measured by using the spectrum of the light. Okay, when they observe from the deep space and inside the sun. Okay, the scientists believe that the temperature is around 10 million degree of Kelvin, and hydrogen bomb, okay, which is a kind of, I don't know, it's nuclear fusion process or something like that. You would get 100 million degree of Kelvin. Okay, that's those million, trillion, billion, and so on are quite far from us on Earth, right? But that's what the scientists or physicists expect in the deep space. Okay, and that's why the Kelvin scale is more universal. Okay, it can capture the tiniest particle until the biggest particle in space, right? Okay, let's compare all these three temperature scale. Okay, we don't talk about the Romer scale, but if you wanna get some idea, you can go to any website, okay, to see the idea of Romer scale. C by 5, R by 4, right? That's the equation. Okay, the freezing point, which is 273.15 Kelvin. Okay, and you can see the pitch here. between two bars on the Celsius and the Kelvin thermometer would be on the same length, okay, but the one by Fahrenheit will have tinier, smaller pitch of 2 bars. And what else? The absolute zero, which is 0 Kelvin, is minus 273.15, and on the Fahrenheit scale, you can get negative 459.67, and here is the abbreviation. Freezing point of water, 32, right? 0 degrees Celsius and 273.15 of Kelvin. Normal body temperature, now 37, right? On the Kelvin scale is 310.15, but you cannot say this number to the department store, okay? Your body is perfect, it's normal. You have 310.15 degrees, but degrees of Kelvin, okay? The people cannot realize that, okay? We use the normal 37 degrees of Celsius when we talk to each other. And on the Fahrenheit, for example, if you live in the United States, they would use this number 98.6 degrees of Fahrenheit. And the boiling point, okay, if you do the laboratory in the United States, they would say 212. But for almost everywhere in the world, we would say 100 degrees of Celsius. And in the strict laboratory, they would say 373.15 degrees of Kelvin. Of course, let's consider other stuff. For example, oxygen try to be in liquid phase at negative 183. Okay, but it's really hard to get this situation. And negative 78. Okay, that's quite in the same level as the keeping temperature for the Pfizer vaccine. Okay, negative 70 degrees. So at this level, negative 78 degrees of Celsius, or 195, or negative 109 in Fahrenheit, the carbon dioxide start to be solid. Okay, the water. Okay, this is what we have already considered. There is difference in 100 Kelvin. Okay, in between the freezing point and boiling point of water, and also 100 degrees in Celsius scale for the freezing point and boiling point of water. But there are 180 degrees between the freezing point and the boiling point on the Fahrenheit scale. Okay, they have more pictures. Okay, they have more details here. If you want to convert the temperature scale from one to another one, you may have to consider this table. If, for example, if you want to convert the temperature from Celsius to Fahrenheit, okay, the output is on the left-hand side, the input is on the right-hand side. You get 9/5 of temperature in Celsius plus 32. And they can also say something like this, okay, without parentheses. From Fahrenheit to Celsius, you have to use the opposite ratio. The reverse ratio, 5/9. Temperature in Fahrenheit minus 32 degrees. Okay, and if you want to convert Celsius to Kelvin, it's quite simple. You just add 273.15 to the temperature in Celsius. If you want to convert the Kelvin to Celsius, you just deduce the temperature in Kelvin by 273.15, and you get the temperature in Celsius. If you want to convert the Fahrenheit to Kelvin, it's like you do the change between Celsius to Fahrenheit. The next thing is that you have to add 273.15 to the result, okay, to get the value for the Kelvin. And if you want to get Kelvin from Fahrenheit, you just use this expression. I don't know, you have to reduce it first by 273.15, and then you convert it by using exactly the same expression here. Okay, 9/5 and plus 32. Okay, that's the whole thing. Yeah, the formula for the conversion between Fahrenheit and Celsius is 9/5. And what else? There is an example in temperature scale conversion. เราต้องจบที่เท่าไหร่นะ 10 ใช่ไหมผมต้องปล่อยคุณ950นะครับโอเค Room temperature is known as 25. Okay, some areas say 20, some areas say 25. Doesn't matter. And what is the room temperature in Fahrenheit, and what is the temperature in Kelvin? Okay, the room temperature in Kelvin. Yeah. Now, กันดาพลเน็ตล่มตามสบายครับสุรปวีณขอโทษครับโน้ตบุ๊กแบตหมดไปสักวันตามสบายครับคุณอยู่ที่ YouTube ก็อยู่กันไปตามสบายนะครับถ้าเสียงติดขัดยังไงแล้วแจ้งผมทันทีนะครับมีคนไหนปกติถ้ามาถึงตรงนี้นะครับเพราะผมไม่ได้ทำโซลูชันไว้ให้เนี่ยผมจะให้คุณทำนะจะให้คุณแก้ปัญหากันนะครับก็มีคนไหนสนใจไหมว่าจะทำโจทย์นี้โอเคไหมไม่ใช่แบบมันไม่มีวิธีทำด้วยนะโอเคไหมมีคนไหนสนใจทำไหมครับมีคนไหนสนใจทำไหมช่วยทำให้ดูหน่อยว่ามันตอบเท่าไหร่นะครับ alright มีใครทำได้ไหมครับมีไหมเลยเปิดไมค์ช่วยด้วยนะครับบางคนอาจจะไปแบบว่าเรียนพิเศษข้างนอกมาแล้วอะไรเงี้ยก็บอกได้นะครับโอเคไหมทำยังไงอันนี้ครับhow could we solve this มีไหมครับพอเป็นออนไลน์ปุ๊บแอคชั่นเราจะไม่ค่อยได้นะโอเคไหมครับก็ถามตอบกันก็จะลำบากไม่เหมือนห้องจริงนี่ผมแรนดอมชื่อนะครับซึ่งมันก็เมื่อนานมาแล้วนะครับที่ได้สอนห้องจริงครับถ้าเป็นห้องจริงเราก็จะแรนดอมชื่อแล้วก็ให้คุณออกมาทำหน้ากระดานนะครับแต่ว่าบรรยากาศนี้มันไม่มีอีกแล้วไม่ใช่ไม่มีอีกแล้วมันคงนานครับโอเคไหมis there anyone who is interested in solving this problem มีไหมครับ anyone interested in this yeah the room temperature 25 right and we want to convert it to the Fahrenheit and to the Kelvin right Fahrenheit and Kelvin so we have to say Celsius to Kelvin and we have to consider Celsius to Kelvin and Celsius to Fahrenheit right so this one right it's what is that T oh no T in F right T in F is equal to this expression 9/5 plus 32 right 9/5 9/5 of T in Celsius plus 32 right and you just leave it it's 9/5 times 25 right and plus 32 you will find that this is 45 right 45 and it's gonna be 77 right 77 Fahrenheit okay no battery at all this one yeah what I forget to mention is the following you need to know that both Fahrenheit and Celsius scale, both Fahrenheit and Celsius scale here, okay, would have the small circle in front of that. All right, yeah. There will be small circle in front of F and in front of C, but for K, which is the absolute temperature scale, there will be no zero at all. Okay, all right. That's the one thing you should realize. Okay, don't be strained to write down a small circle in front of K for the unit of the temperature. Oh no. For the temperature by Kelvin, okay, there will be no circle at all to that. Yeah. All right. Yeah. It's the next thing. Now we arrive at the problem of Kelvin, right? TK is 273.15, right? Plus TC, right? And yeah, it's 273.15 plus 25, right? So it's gonna be 298.15 Kelvin, okay, without the small circle at all. All right. And forget this. Let me change. And SI. And all this. All right. On page 26, right? Okay. Yeah, here. Next thing. We arrive at the next example, which is here. Oh no. The temperature unit conversion problem. อันนี้ผมผิดนะครับ moment bracket in all system. All right. Yeah, we arrive at the next example, and here is the temperature gradient between the skin and the air is regulated by Kutan. Who know this word? มีใครทราบคำนี้ไหมเป็นศัพท์แพทย์นะผมเรียนวิศวะนะครับไม่ได้ยุ่งกับศัพท์พวกชีวะมานานโขนะครับไม่คุ้นเคยเลยนะครับ Is there any idea about that cutaneous skin blood flow, right? And if the cutaneous blood vessel ภาษาไทยเรียกว่าอะไรเส้นเลือดฝอยหรือเปล่าใช่ไหมเส้นเลือดฝอยไหมครับ Alright, is that correct? ใช่ไหมคนไหนเก่งชีวะครับคำนี้แปลว่าเส้นเลือดฝอยใช่ไหมครับyeah, if the cutaneous blood vessels are constricted, the skin temperature and temperature of the environment will be about the same. All right, and when the vessels are dilated, more blood is brought to the surface. Okay, when the vessel is expanded. Okay, and the body uses this system to control the temperature inside our body. And yeah, suppose during dilation the skin warms to in 82 degrees of Celsius of Fahrenheit, sorry, and convert this temperature change the temperature change from Fahrenheit to Celsius and from Fahrenheit to Kelvin. Okay, and again find the difference. Okay, yeah. Yeah. Is there anybody who is interested in solving this problem มีใครสนใจไหมครับมีไหมเอ่ยทำออนไลน์แล้วเปิดกล้องให้เพื่อนดูหน่อยก็ได้นะครับเขียนมา anyone who is interested in มีใครสนใจไหมครับ anyone who could solve this เน็ตล่มมีแย่งกันต่างๆนะครับที่อีกช่องหนึ่งไม่มีใครดูนะก็ประมาณนั้นครับโอเค alright here and okay yeah we have to convert first the 72 to 84 right in yeah F2C right F2C so let's take a look at the table I also cannot remember okay F2C is gonna be this one okay Fahrenheit to C 5/9 okay T 72F right is gonna be converted to T in degree of Celsius right so we would formulate this one by using this expression T F right in minus oh no 9/5 right 5/9 32 right and then 5/9 okay and we leave the temperature of F into this expression all right 5/9 divided by 72 minus 32 and it's gonna be 5/9 times 40 right and yeah we leave it in the calculator right 200/9 okay let's say it's 200/9 it should be something around 10 right 200/9 200/9 let me close the microphone 200/9 it's gonna be generate 22.22 okay it's approximately 22.22 and the unit for this is degrees Celsius right yeah and let's continue our story in the next thing is 84 right so T C right equal 5/9 of 84 minus 32 right it's gonna be 5/9 and 5/2 right 5 and 2, and we get 260 by 9. All right, and yeah, let's use this one. Okay, simpler. 260 by 9, 28.88. Okay, 28.89. Okay, approximately, and that's the unit in degree of Celsius. And what else? The difference, right? The difference. So it's gonna be delta T in degree of Celsius is gonna be 28.89 minus 22.22. It's approximately 7 and 6 and 6.67. Okay, another way is that you can change the difference here. You can see the difference, which is 12, right? 84 minus 72, right? It's 12, and you just use 12 times 12 times 5 by 9, right? It's gonna be the same thing. 6 here, right? 6.67, 6.6666. All right, here you can use the difference and times the scaling factor 5 by 9. All right, in order to find the difference. Okay, or you can find the difference directly from both values. So let's consider the temperature in Kelvin, right? Kelvin. Kelvin is quite simple. You just 273.15, right? Plus temperature in degree of Celsius, right? At the first state, T1 is this one, right? 22.22, right? So it's 273.15 plus 22.22. You would get approximately 295.37. This is in Kelvin. For the second temperature, you get 273.15 and plus 28.89, right? And you get yeah, here 4. This is approximation. 10 ผมต้องปล่อยคุณแล้วสิมาก่อนจบอันนี้กันแล้วกันนะครับเลยนิดนึงนะผมเซตเครื่องเสียเวลานะครับขออีกสักจนถึง10 โมงแล้วกันนะครับ5 and 9 is going to be 4, right? And this is 0 and 1, right? It's 12 and 1 again 29, 3 and the 2, right? 0.04, right? Let me check it in computer เพื่อความชัวร์นะมันสอนคุณอัดนะครับเดี๋ยวบวกเลขผิดครับ 273.15 plus 28.89 oh my god 273.15 plus 28.89 3. Yes, it's correct here. Okay, second temperature, and you get the difference, right? You want to find difference, so delta T is equal to T2 minus T1, right? And is equal to R7 and 9.6, 9.3 is going to be 6, and 11.5 is 6, right? And something like that. And you can see the difference here. This is in degree of Celsius. This is in Kelvin. Okay, you can see the difference on both scales are the same. Okay, the differences on both scale, whether it's in Celsius or Kelvin. Are the same. Okay, 6.67. So the next thing, the next example, right? ขออีก1ตัวอย่างนะครับแล้วก็จบตรงนี้นะครับแล้วก็สั่งกันบ้านครับ normal internal body temperature for an average healthy human is 98.6 degree of Fahrenheit in find this temperature in degrees Celsius and in Kelvins. Okay, that's the first equation. Let's do first, okay? Normal temperature is something like that, and convert it to the Celsius and Kelvin, right? So TC first. TC is 5/9, right? And TF minus 32, right? So leave the 98.6 5/9 and 98.6 minus 32, and use the calculator. We get 5/9 times 98.6 minus 32. We get exactly 37. My God, it's not approximation. Exact value 37 degree of Celsius. Okay, that's the normal body temperature. And if you want to find it in Kelvin, you can add it to 73.15, right? Plus T plus the temperature in Celsius. So 273.15 plus 37. So it's gonna be 310, right? 310.15, and the unit here is Kelvin, right? Now in the second situation, find this temperature. When human is relaxing on a couch, the skin temperature is about 2 degrees Celsius lower than the internal temperature. And how much lower is the skin temperature in Fahrenheit degrees and in Kelvin? So you can see that there is the difference in difference by 2 degrees of Celsius, right? Delta T is 2 degrees of Celsius, right? And we want to find it in Fahrenheit, right? So you know that if you want to convert TF, right, to TC, right? So it's gonna be 9/5, right? 9/5 of let me take a look at the table. Celsius to 5, 9/5 and plus 32. TZ and plus 32 degree of Fahrenheit, right? So we have if you want to find delta T in F, right? Delta T F, this is delta T in C, right? Delta T in F, delta T in C. You just use the factor 9/5, okay? And what happened? There is internet connection problem because it get lost. No. There is internet connection problem. Sorry for that. And we have to. Okay, now done. Yes. Okay. All right. Yeah. You just use 9/5 factor and leave it to the factor TC, okay? And it's going to be 9/5 and number 2, right? So it's 18/5, right? So it's equal to 3.6 degree of Fahrenheit, right? But regarding the temperature difference in Kelvin, okay, because of this expression, T Kelvin is 273.15 plus T in degree of Celsius, delta TK is gonna be directly the same as delta TC. All right, so it's, as you know, this one is the 2 degrees different, right? 2 degree difference, so it's gonna be 2, right? Kelvin. Okay, and that's it for this example. Alright, หมดเวลาพอดีนะครับก็ 10 โมงครับก็แจ้งคุณนะครับการบ้านนะครับได้เป็นคะแนนเก็บครั้งท้ายๆนะครับ อย่าพลาดนะครับ การบ้านให้เลือกเอานะครับก็คือเรื่องคราวที่แล้วนะคือเรื่องเขาเรียกว่า epsilon t เท่ากับบานโอเมก้าไซน์โอเมก้า t นะครับแล้วผมเขียนใน Google Classroom ให้อีกรอบหนึ่งเรื่องการบ้านนะครับย้ำนะครับการบ้านนะครับเลือกได้นะครับ2เรื่องนะครับก็คือเรื่องtemperature change นะครับตรงนี้นะครับก็คือการเปลี่ยนยูนิตของอุณหภูมินะครับจากตารางนี้แล้วก็อีกเรื่องหนึ่งก็คือเรื่อง generator นะครับก็คือ epsilon t equal bar omega sine omega t. All right. Is there any question regarding the lecture of today? มีคำถามไหมครับ Do you have any question? If not, we're gonna leave our lecture right now, okay, and see you on next Thursday. Okay, next Thursday. สวัสดีครับบ๊ายบายครับ Next Thursday. No one is there, right? alright โอเคครับSCI33205 welcome you to SCI33205 this is the section for M605 right and I have two things to inform you right let's check the sound all right yeah two things that I have to inform you is the following the first one is something about the midterm the final exam right yeah as same as in midterm exam okay we are gonna have 2 times for the exam okay so that you can get less stress and you can have more time and of course we have the content in the second chapter right in you can have 1 week to remind yourself about the second chapter and we would have the final exam on the 10คนมาที่หลังครับวิชอะไรจะรู้เรื่องไหมครับโอเคสำหรับปฏิหารครับสำหรับคนที่มาทีหลังครับก็จะพูด2เรื่องครับวันนี้ครับนอกเหนือจากเนื้อหาที่จะเรียนกันครับจะแจ้งคุณ2อย่างก็คือเรื่องแรกนะครับก็คือ the first thing is the midterm exam the final exam all right and because we have 2 chapters right second chapter and the 4th chapter that we are dealing with right now and for the second chapter we will have the exam on 10th of September is that all right to you no 10 is not possible it would be yeah it would be possible 10 okay I hope that because I have also the class for teaching on the 10 I hope that on 10 which is on the next week right นะวันที่10จริงๆผมติดนะแต่ว่าสอบคุณไม่ต้องออกเสียงอะไรครับก็สามารถสอบคุณได้อยู่มั้งครับall right yeah on 10 which is yeah it's Friday it's no problem there is no conflict at all on 10 we would have the final exam I'm not sure whether you could see okay on 10 of 10th of September we would have the final exam for the second chapter which is something about magnetism and electricity all right พิรทัศน์เพิ่งมาจะทราบนี่เพื่อนบอกด้วยแล้วกันครับ and I will tell you later about the number of problems but it's in the same style as the midterm exam okay you have to choose the number and the problem is exactly the same as in the lecture notes and yeah because I need to have more time okay to avoid the error in checking your problem in the exam okay to avoid the errors so I need to have more time otherwise if you let me do it for only few days 1 or 2 days it's very stressful and it's prone to error it's quite sensitive to the error so after 10 we would have the exam again we would have the exam again on 17. Okay, that's the last day we could do the final exam, and we have almost 1 week. All right, and yeah, and the final score should be delivered to the school on 19, and the grade submission will be done by your co-teacher at the SK school on 21st. All right, so it's the grade will be filled into the system by your co-teacher, and yeah, that's what we could do. I hope that everyone in M605 has submitted his own homework completely, perfectly already, right? And I don't know what's going on with Tilut. Maybe we would leave him, I think. But some of you say that he has left the school because he has got the right to the military school, and but your co-teacher, the teacherสุคุณครูอะไรนะคุณครูผมลืมชื่อแล้วนะครับผมดูแต่ชื่อเล่นครับโอเคไหมyour co-teacher said to me that I have still keep the record for T-root, so that's why I didn't remove him from any file at all, right? And that's the first thing. Okay, all right, about the final exam. 10 next week or next Friday for the second chapter about magnetism and electricity. Anything that is succeeded from the content in the midterm exam. Okay, we will have it as the final exam contents until the end of second chapter, and we would have few problems for the fourth chapter, which is this chapter, the heat and gas. Okay, all right, that's the first topic we were discussing, and the second topic is that the second story is that I have to inform you that we would have homework. Okay, I don't know, this might be the night homework, I don't know. Yeah, okay, the night homework will be the problem about generator, which is epsilon equal bar omega sine omega t. Okay, that's the first choice for you. For the second choice, I'm not sure. For the second choice, I'm not sure I have shared the screen. Not yet, right? Okay. For the second choice, the second choice is that you can do also the homework regarding the temperature conversion, which is gonna be shown here today. This for today lecture, this one. Okay, the problem about the conversion of the temperature units. Okay, Celsius to Fahrenheit to Kelvin, Kelvin to Celsius, Fahrenheit, Kelvin, Kelvin to Fahrenheit. Okay, we will have 3 examples for the conversion of temperature, different temperature units like this. Okay, and you can also choose this one as a choice. Okay, in summary, the first choice for you to do the homework is the generator, okay, which has the formulas epsilon t equal bar omega sine omega t. Bar mean BAN, okay, B magnetic field, A is the cross-sectional area, N is the number of turns of the coil, and omega is the angular speed of the rotation axis or the rotor, and sine omega t, right? And that's the first choice. The second choice is the temperature conversion, which is what you are gonna see here in today's lecture. All right, everything is fine, right? I hope that nobody is gonna have any trouble with the final exam. The exam style would be the same. Okay. Yeah, we have stated already the something about the temperature, right? We have talked about this one, temperature. Okay, as we know from yesterday, temperature is like the height, okay, and the height of your body, and heat is like the mass, okay, mass of your body, and yeah, here we have discussed this yesterday. The temperature, the thermometer, that is the tool to measure the temperature, right? And the liquid inside can be either mercury or ethanol, okay, which is a kind of alcohol. And yeah, the freezing point for the water is at 0 degrees of Celsius, and the boiling point of the water is all right, everything is fine. The boiling point of the water is 100 degrees of Celsius. And is there anything else? Yeah. The way we could measure the temperature could be in many aspects. Could be done in many ways. The first way is that you can observe the volume of the liquid, okay, which is a kind of what you can see here inside the thermometer. All right. The next thing is that if you have a piece of metal bar and you inject the heat, okay, you put the heat to it, and the bar is gonna be hot, and it can increase its length, okay, and yeah, that's one way. And have you ever seen the railway for the train? ใครเคยเห็นรางรถไฟไหมครับเคยเห็นไหมเคยเห็นรางรถไฟไหมครับถ้าคุณเคยไปสถานีรถไฟคุณจะเห็นรางรถไฟคุณจะเห็นว่ารางรถไฟเหล็กรางรถไฟนะครับมันไม่ได้เป็นเหล็กเส้นเดียวกันแล้วต่อเลยนะไม่ใช่แบบเหล็กยาวเส้นเดียวกันคู่ขนานกันไปตลอดไม่ใช่อย่างนั้นนะมันเป็นเหล็กทีละชิ้นทีละชิ้นแล้วมาวางเรียงๆกันเห็นไหมครับเห็นไหมเอ่ยนั่นแหละนะครับเดี๋ยวพาไปดูเหล็กรางรถไฟดีกว่า Let's consider this. I'm not sure whether we could see it or not. All right. Is there any example to that? Oh no. here I hope that there would be some image so that no no let's consider the image where here, okay, here you can see, right? You can see here, right? There is an there is a space here. Okay, you can see that the piece of metal is not a single one. Okay, there is it's made of two pieces of metal. What is the reason behind it คุณทราบไหมครับว่าทำไมเขาเป็นแบบนี้ทำไมเนื้อเหล็กต้องเป็นเหล็ก2ชิ้นแบบนี้มีตัวอย่างอื่นอีกไหมoh no here alright yeah มีใครตอบได้ไหมครับเปิดไมค์ตอบหน่อยว่าผมอุตส่าห์เสียเวลาหา ทำไมเป็น2ชิ้นแบบนี้ทำไมเขาไม่เอาเป็นเหล็กเป็นอันเดียวกันไปเลยทำไมไม่เชื่อมออกติดไปเลยเป็นแบบติดกันแบบกาวตาช้างเป็นแน่นเป็นชิ้นเดียวกันทำไมวางเชิญครับเชิญอะไรนะครับมีคนตอบแล้วเนี่ยใจคุณจะเห็นรอยต่อเนี่ยเห็นไหมครับเนี่ยมีตลอดมันจะยาวสัก100 เมตรหรือว่า70 เมตรอะไรเงี้ยมีคนตอบไปแล้วนนทกรบอกว่าป้องกันการขยายตัวคุณเห็นไหมเหมือนกันนั่นแหละครับเรากำลังเรียนเรื่องวัดอุณหภูมิของสิ่งของเนี่ยเห็นไหมเนี่ยคุณเห็นไหมครับเนี่ยร่องสีเหลืองเนี่ยครับเห็นไหมเอ่ยนั่นแหละคุณจะเห็นว่าเขาเหลือไว้เห็นไหมเอ่ยอย่างที่นนทกรบอกนะครับก็คือว่าเหล็กมันอยู่ข้างนอกมันไม่ได้อยู่ในอาคารในร่มนะครับมันโดนแดดใช่ไหมครับพอโดนแดดมันทำเป็นไงมัน get heat มันได้รับความร้อนนะครับมันก็เรื่องนี้เลยนะครับเนี่ย length of a solid alright นะครับไอตัวเหล็กรางรถไฟก็เป็น solid เป็นของแข็งชนิดหนึ่งพอมันโดนความร้อนมันจะขยายตัวนะครับขยายตัวออกข้างด้วยด้านยาวด้วยโอเคไหมพอมันด้านยาวเขาก็ต้องเหลือที่ไว้นะครับไม่ใช่แบบว่าจับชนกันเป๊ะๆนะครับโอเคไหมถ้าเป็นคนซื่อตรงเขาก็คงเคยลองสร้างมาแล้วแหละแล้วปรากฏว่ามันผิดพลาดนะพอมันดันกันนะครับถ้ามันชนกันเลยนะจับวางทีแรกไม่โดนแดดเนี่ยจับชนกันปุ๊บพอโดนความร้อนปุ๊บมันจะดันกันนะครับพอมันต่างขึ้นอันนี้ก็ยาวขึ้นมันก็ชนกันโอเคไหมอันนี้เขาเหลือไว้เพื่อว่าเหล็กพอมันโดนความร้อนแล้วนะครับโอเคไหมมันก็จะขยายตัวนะครับso we use this principle too alright in order to observe the temperature increases of any stuff okay another one is the pressure of the gas held in a constant value if you have a constant value glass you get more pressure from gas okay when you put the heat into it in if you keep the pressure constant and if that subject can be expanded for example the balloon okay balloon is an example this one okay yeah this one if you lay down the balloon outside มีคนหมายเลข20หมายเลข20นี่คือใครไม่เขียนชื่อมาผม alright if you have the balloon like this and if you leave it outside for example with the sunlight. Okay, it gets heat, okay, from the sunlight, and you can see that if the pressure inside the balloon stay constant, the volume of this balloon is going to be bigger. Okay, so that's the case here. This one, we keep the pressure constant, and we fix the pressure, and we get the increase of volume of a gas. Okay, another way is this one. What is that? Okay, this one. I don't know. Oh no. This one. Any figure. Here. This one. Right there. Oh no, my god. มาที่ซื้อของเลย Okay, right here. You know this, right? This is the water pipe. Okay, then the water is the water from around the engine. Okay, it gets heat from the engine combustion, and this one is our target. It's the piece of sensor. อันนี้ไม่ได้ขายของนะ here, all right. It's a piece of sensor, and this one is put into the water flow, all right. And there's black and red conductor Y. Okay, the current will flow from the red one and return to the black one. Okay, you know this is the sensor, and the task of this sensor is the following. If the temperature increases, due to the hot water flowing around the engine, the resistance of this one is going to be also increased. Okay, when the resistance of this piece increases, it will let the current flow more difficultly. Okay, there will be less and less current flow. Okay, the current will not flow. The amount of current flows is gonna be reduced. Okay, if the water flow with more heat and more hot water, the resistance of this piece is going to be more and more increases. When the resistance increases, there will be less current flow from the red one to the black one, and the car use this signal to measure the tail of the water in the radiator, okay, in front of the car. All right, yeah, that's the way we use. That's the technique we use to measure the temperature. Okay, many ways: the length of the solid metal, and metal bar, the pressure of the gas, the volume of the gas, while another parameter like water and pressure has to be kept constant. And what else? Electric resistance, right? Like the sensor in the radiator, and the color of very hot object. Okay, you can also observe several temperatures from the color. For example, the physicists analyze, okay, or infer the information of the temperature at any star by using the light spectrum. Okay, I don't know the chart of the color, but the physicists use this technique. Okay, because we cannot go by spacecraft to a very, very far star. Okay, the star that is very, very far from us on Earth. Okay, because that will consume, it will take a lot of money to do that, or even it's impossible at all because the star is too far from us. Okay, the possible way that scientists can expect or guess or determine the temperature on any star or planet is to use the color of that star. Okay, no, sorry, the planet and the star and so on. Okay, several properties of any star that we are interested in. Okay, temperature is a measure of hotness and coldness on some scale, but what scale do we use usually นะครับก็แล้วเราจะคุยกันด้วยหน่วยอะไรนะครับเพราะว่าใครก็บอกว่าร้อนนะครับร้อนมากร้อนน้อยเย็นมากเย็นน้อยแต่ว่ามนุษย์สื่อสารกันมันก็ต้องมีอะไรที่เป็นแบบ common นะครับไว้เทียบกันนะครับไว้คุยร่วมกันเข้าใจร่วมกันได้นะครับนั่นก็คือหน่วยของอุณหภูมินั่นเองครับ All right, so the most common temperature unit that we are faced with in daily life or we encounter every day is okay is given by this person while I was really young, like a child in Mathayom 3. I was chosen as the in primary school. I think in primary school I was chosen as the candidate of the school to attend the competition of scientists of science and so on, right? And in that time, at that time, I was taught to know the temperature unit, and it's called centigrade. Okay, at that time it was called centigrade. It's like ตอนไหน12 ขวบใช่ไหม11 12 ขวบตอนนี้ก็ประมาณ30 ปีที่แล้วนะครับโอเคไหม30 ปีที่แล้วเป็นเรียกว่าเป็นตัวแทนโรงเรียนครับไปตอบปัญหาเกี่ยวกับวิทยาศาสตร์ครับ and I was taught to get to know the temperature unit, and it's known as centigrade at that time. Okay, but when the time goes by, this word is not used, is no longer used. You can hear this word in the ancient book, okay, in the book that is really old, okay, the very old book. You can hear this one, okay. It's known as centigrade at the beginning, okay, and the C letter is chosen as the abbreviation unit. Okay, you can see the alphabet C, but when the time goes by, they have changed the new way, the new word. I think maybe this person has passed away already, I don't know, but the C is actually came from the word Celsius, and Celsius is the surname of this person, Anders Celsius. Okay, and I think it would be very old generation, because if you look at his hairstyle, it would be in the same era, same generation as Napoleon Bonaparte or something like that. Okay, because usually we don't have such type of hairstyle nowadays. And the centigrade scale or the Celsius scale is based on the basic property of the water. All right, and what properties of the water we are interested in. So the scientists pay attention to two things. The first thing is the boiling situation of the water when the water changes its phase from the liquid phase from liquid to gas, right? And the next point, okay, the second important point is the freezing point. Okay, that's the temperature when the water changes again its phase from solid to liquid, or from liquid to freezing point. All right, or melting point. Okay, it's the same thing. And this is built up by Celsius. Okay, Celsius. That's why we say degrees of Celsius nowadays. And the temperature of substance colder than freezing water is gonna be considered as negative. Okay. For example, have you ever been in Siberia? Let's talk about Siberia. Okay, which is oh no, my God. Oh no, what happened? Question ขออภัยนะครับเน็ตผมหลุดนะครับ my God เน็ตผมหลุดนะครับขออภัยด้วยนะครับอยู่ดีก็หลุดนะครับ alright this one okay in Thailand maybe we would not have that situation Siberia no Siberia in Russia right yeah Siberia with S okay Siberia in Russia it's written in here oh no here Siberia okay this is a part of Russia and you can see their location and in winter here you can see the weather there in winter they can have like in January for example they can have like -20 okay and the highest amount is -12 okay and in the worst situation they can have even during the night time okay -50 degrees of Celsius okay it's very hard to live there and the people would not go out to work at all okay because it's really hard to get out of the home and yeah there will be always the snow imagine this right yeah okay it's very cold there and yeah we get the temperature which is really less than freezing point of the water and we would say it's a negative number in degrees of Celsius okay and the Celsius scale is used both in everyday life and in science and industry okay if you plan to work as scientist on the laboratory มีคนถามผมว่าผมหลุดแน่นอนเลยมีคนถาม605ใช่ไหมเสียงหายครับ1050 oh I'm sorry for that เสียงหายที่YouTube มันจะมี2ช่องนะคุณลองดูก็ได้นะครับดังนั้นจะใช้ไมโครโฟนอีกอันหนึ่งนะครับไม่รู้ผมส่งลิงก์ให้คุณแล้วหรือยังครับที่เดี๋ยวหาลิงก์ให้ได้ครับอันนั้นจะเห็นตัวผมด้วยนะอันนี้เห็นแค่หน้าจอนะเดี๋ยวส่งลิงก์ให้แล้วกันนะลิงก์ที่ YouTube ตอนนี้ก็มีคนดูอยู่ประมาณ2คนครับ แต่ลิงก์อันนี้มันแต่ YouTube ที่คุณดูนี่มันเป็นมาจากซูมอะถ้าซูมเสียงหาย YouTube ก็จะเสียงหายด้วยครับ แต่ว่ามันจะมี YouTube อีกอันหนึ่งครับที่แบบพิเศษเลยอ้าว what's going on if we have live right เสียงมาแล้วหรือยังครับเสียงครับlive stream I'm not sure about the live stream this one it's in yeah this one the link hereเดี๋ยวส่งให้นะครับอันนี้นะลองกดลิงก์นี้ดูนะครับต้อง copy ไม่รู้คุณเข้าได้หรือเปล่าวันนี้นะครับand yeah we have this my channel แล้วพี่พลครับคือผมไม่เข้าใจว่าทำไมอีกการหนึ่งไม่ขึ้นครับไลฟ์อีกการหนึ่งวิดีโอI don't know okay you may SCI33205มีไหมเอ่ยที่มันกำลังไลฟ์ทำไมมีอันเดียวไม่เข้าใจครับจริงมันมี2อันนะแต่ลิงก์ที่ผมส่งพิมพ์ไปในไลน์นะครับนั่นคือที่ไลฟ์อยู่นะครับ I'm not sure it's private or stream setting มัน private หรือว่าเพราะว่าพวกอันนั้นเขาก็พวก604ครับมัน private หรือเปล่าผมไม่รู้นะทำให้คุณเข้ากันไม่ได้หรือเปล่าจริงด้วยนะเซตเป็น private ไหมก็โอ้ไม่ก็ไม่น่าเลยต้องห้ามทำเป็น private ผมดันไปเซตเป็น private ครับมันก็เข้าไม่ได้เลยครับโมเมนต์มีหน้าครับไม่มีคนไปดูที่อันนั้นนะครับมันเป็น private นี่เองกดสวงวัดนี่ห้อง5แน่นอนดูที่ไลฟ์สตรีมโอเคมาเดี๋ยวลืมเรื่องของเรานะครับif you plan to work in the laboratory every day okay you may have to you may have to use the Celsius degree and if you plan to work as engineer okay all right yeah it's you may also have to face with the อันนี้ดันไปเซตเป็น private and yeah then นะครับน่าจะเข้าได้นะครับอันนั้นไม่เซตเป็น private นะครับ and, yeah if you plan to work in as engineer in a factory, like many students of mine. In the factory, they also use the degree of Celsius. Okay, the Celsius degree, and you can see that Celsius degree is used for a lot of application. Now, but in some countries, like in the United States, we don't use this unit. It's called, we would rather use Fahrenheit, okay, in countries, except for United States too. Okay, they use Fahrenheit, okay. The Fahrenheit is the surname from Daniel Fahrenheit. I think he is Polish. Fahrenheit scale is still the most frequently used temperature unit in the United States and has the freezing point. Okay, the freezing point of water at 32 degrees of Fahrenheit and boiling point at 212. Okay, which is 180 degrees as difference. Okay, and what else? If you look at the scale on both scales on the same thermometer, you will see that the boiling point is at 100 degrees at the Celsius side, and you will get 212. Okay, on the Fahrenheit side. You get the freezing point 0 degree. On the Celsius side, you get 32 degrees of Fahrenheit on the Fahrenheit side. And the human body, the normal temperature for the human body is 37 degrees on Celsius scale and 98.6 degrees on the Fahrenheit scale. Okay, and the room temperature is considered to be 20 degrees of Celsius and 68 degrees on the Fahrenheit scale. Okay, but it's not easy to find 20 degrees of Celsius outside in Thailand. Okay, I don't know why they say it's room temperature if you turn on the air conditioner heavily. Okay, but those two scales are not the only scale that is used around the world. Okay, in daily life, okay, both scales would be sufficient, but if you work in a special area in physics or in many applications in chemistry too, you may have to consider the next temperature unit, which is this one. Okay, how does the temperature how does this temperature unit emerge? Okay, they just many scientists have a chance to do the experiment about the phases, okay, the states, whether it's liquid, solid, or gas, of many things, and they may have a chance to see the behavior of several kinds of gases, for example, this one, and if they control the volume of the gas to be constant, okay, to keep the volume of that gas constant, and if they let the temperature be higher, what they could observe is the increasing amount of the pressure too. Okay, there is an increasing pressure too. Okay, in they have tried. They have done this experiment for many types of gases. For example, the red one is the first experiment for the first gas. The blue one is the same experiment. When we increase the temperature, we get higher pressure too. In the last one, okay, they use 3 different types of gases, and yeah, beyond the temperature by the water freezing, the water freezing points, they expect that if they plot everything onto the appropriate scale, they observe that all these experiment tends to bring you to the same point, okay, when the same point where we cannot find any lower temperature possible, okay, and we will not find any lower possible temperature anymore. And this is the same point for every gas, okay. And yeah, they found that the heating point here on the x-axis, on the temperature axis, is equal to minus 273.15 degrees of Celsius. Okay, so when we know that when they know that 233 degrees of Celsius is no longer appropriate, is no longer convenient for every people to use it, they just build up a new temperature scale, okay, but the pitch or the resolution will be the same as the Celsius scale, okay, because that the scale that the most people use it. All right, yeah, and here is the reason why it comes to this scale. Okay, this scale is was in part discovered by this person, and it's called Kelvin scale. Okay, but Kelvin is not like Celsius or Fahrenheit. Kelvin is the surname of this position. Okay, it's not the the name that he was born. He was get why he was born. Okay, his actual name is William Thomson, but as he, if you have done something good to the society, to the community, you will get the special rank. Okay, like imagine that if you watch the soccer or the football in soccer in American, or football in other parts of countries, in other part of the world, we would say football as the soccer, right? But in the United States, you have to say soccer. Otherwise, if you say football, it's gonna be the American football, yeah, NFL and so on, right? And yeah, but imagine that if you are the trainer of the soccer team like Manchester United, but I'm not the friend of Manchester United, okay? And you know that there is a person who is the trainer or the coach of Manchester United, and he was born like a normal people, and when he has done something good to the squad, to Manchester United, they got several prizes, UEFA Champions League and so on, right? And he has got the rank which is called Sir, right? SIR. Yeah, and the typical British system, they have also the rank like Baron Kelvin, and William Thomson was the first person who got this special rank. Okay, and the temperature scale just follow his name. Okay, maybe he got the rank due to his contribution, his work in science or in physics, like that. Okay, นะครับประเทศไทยผมไม่รู้นะถ้าคุณเป็นนักฟิสิกส์ไปเรื่อยๆคุณคิดค้นพบอะไรคุณอาจจะได้รับตำแหน่งยศอะไรก็ได้นะหรืออาจจะขออนุญาตนะครับอาจจะได้รับอะไรนะเครื่องราชอิสริยาภรณ์อะไรอย่างเงี้ยนะคล้ายๆกันนะครับเพราะว่าไทยก็ไปใช้มีลักษณะสังคมอย่างเงี้ยคล้ายๆกับประเทศอังกฤษมาครับ All right. Kelvin is not the actual surname of any person, but it's the surname of this position, of this rank. Okay, we have to deal with Kelvin scale because it's the temperature that is commonly used in science. Okay, if you want to work in laboratory, you cannot avoid to work in to use the Kelvin. Okay, especially in the faculty of science. Okay, for us in in engineering, we would not often use the Kelvin scale. Okay, I have never heard the Kelvin scale in engineering. Okay, except that you work in faculty of science, you fall in love with chemistry, you fall in love with physics. If you want to work there in the university with this stuff, okay, you have to deal with Kelvin scale. Okay, it's like if you live in the United States, you are gonna say your height in terms of foot or feet, right? 6 foot, 6 feet, 3 foot, 3 feet, something like that. Okay, and you say you will say your weight in pound rather than kilogram. All right, yeah, that's the thing. And you would say the length in inch or foot or something like that. Yeah. Kelvin scale is special for the people in laboratory in science, and this temperature scale is quite unique because it's defined to have 0 Kelvin for any substance in the space. Okay, you cannot get minus or negative infinity Celsius or minus infinity Kelvin. Okay, it's impossible. Okay, it's not on the real life like mathematics. In physics, you have to rely on the truth. Okay, they found that 0 Kelvin or minus 273.15 is the lowest possible temperature of anything in the space. Okay, you cannot get the temperature less than this. Okay, and that's the thing that we have to rely on. And yeah, so because of this reason, they would say that Kelvin scale is the absolute scale for the temperature. And what is the reason why they say absolute? Because the 0 value on the Kelvin scale is the lowest temperature that we could have for any stuff. Okay, what is the reason why they say is the absolute absolute 0 temperature? Because Baron Kelvin has found that when we are at 0 Kelvin, the molecules stop moving. Okay, they don't move at all. When they don't move, there will be no kinetic energy. You know kinetic energy, right? The energy due to the movement of any particle, and it can be found from the expression that you may get used to, right? It's 1/2 mv square, right? Yeah, at that temperature you would get 0 motion for anything. So in that situation, there will be no kinetic at all. Okay, kinetic energy at all. Yeah, so that's why they say it's absolute 0 and absolute scale, temperature scale. Absolute 0 is the temperature at which everything, including air, freezes solid. Okay, if someday if our body can sustain or stay in that environment minus 273.15 degrees of Celsius, if human can stay like that, you will see that the air will get the solid phase. Okay, there will be no no gas form of the air anymore. And I don't know, in that situation, how could we breathe then? Yeah, because when the molecules or the atom of the air don't move, okay, there will be no energy. Then when there is no energy, the matter is gonna stay in solid phase. Okay, very very low internal energy. So unlike temperature scale, Kelvin scale is an absolute scale. Okay, the other scale like Celsius, Fahrenheit, and you know that there is an additional temperature scale. What is that? The one that I didn't say in this lecture. There is also another temperature scale Have you ever heard that maybe during your time in Mathematics 3, Mathematics 4, Mathematics 5, you may have ever heard that temperature scale, but it's not addressed, it's not said in this lecture notes, in this lecture, in this SCI33205. What is that temperature scale? คุณคิดว่าหน่วยพลังงานหน่วยอุณหภูมิอะไรนะที่มันยังมีอยู่แต่ว่าเราไม่ได้พูดกันเลยนะเนี่ยคุณคิดว่าหน่วยพลังงานอุณหภูมิหน่วยอะไรครับที่ยังไม่ถูกกล่าวถึงเลยและในนี้ก็จะไม่มีกล่าวถึงด้วยมีไปแล้วคือเซลเซียสมีฟาเรนไฮต์มีเคลวินมีอีกอันหนึ่งอะไรครับเคยได้ยินไหมเปิดไมค์ตอบได้นะเชิญเลยครับหรือว่าพิมพ์มาก็ได้นะครับมีใครตอบได้ไหมครับมีไหมอันที่ซูมเป็นไงบ้างซูมเหลือ2 คนเหมือนเดิมครับ alright เข้ามาพิมพ์ชื่อแล้วก็หนีกันไปแล้วนะครับรวิพลครับมันหลุดไปเมื่อกี้นะครับแต่ว่าสั่งอัดแล้วนะครับก็น่าจะอยู่ในนั้นนะครับมีอีกหน่วยหนึ่งของอุณหภูมิไม่ใช่แบบว่าสอนไปพาคุณไปโลกแคบๆอย่างนี้ไม่ได้บอกให้มันรู้กว้างๆทั้งหมดเดี๋ยวจะหาว่าผมแบบเรียกว่าไงรู้ไม่กว้างแล้วก็เอามาบอกคุณนะครับผมก็ต้องบอกคุณทั้งหมดนอกเหนือไปจากนี้มันยังมีหน่วยอุณหภูมิอีกอันหนึ่งเรียกว่าอะไรมีใครตอบได้ไหมครับที่ YouTube นะครับมี กฎชวงวัดนะอยู่นะครับแล้วก็ละวิปลอยู่นะครับที่ YouTube มีเหมือนเดิมนะครับมีนนทกรกับปณทัศน์นะอยู่2 คนนะครับคิดว่ามีอะไรนะที่อาจารย์ยังไม่ได้พูดแต่จริงๆมันมีนะคุณผมก็ไม่เคยเห็นเขาใช้กันหรอกนะครับแต่ว่าเรียนมาเนี่ยมีอยู่เคยได้ยินอยู่สมัยม.เหมือนคุณนี่แหละหน่วยอะไรครับอีกอันหนึ่งหน่วยอะไรWhat is the next What is another temperature unit that was not discussed yet in this lecture Another temperature unit is Romer okay you know Romer รู้จักอุณหภูมิหน่วย Romer ไหมครับโอเคนั่นแหละนะครับ Romer ไปศึกษาเองนะครับกด Romer ROMER นะครับในอินเทอร์เน็ตครับมันก็เป็นหน่วยอุณหภูมิอีกอันหนึ่งนะครับในที่นี้เอาเท่านี้นะครับเพราะว่าแค่นี้ก็สอนไม่หมดแล้วนะครับ Alright yeah Romer is another temperature unit yeah here we have the volume of gas in the flask and หลอดทดลองเนี่ยครับโอเคไหม is kept constant by raising and lowering the reservoir B okay we can lift it up and lower it down make it lower to keep the mercury level in column A constant okay yeah นะครับวิธีทำให้ปริมาตรแก๊สมันเท่ามันคงที่นะครับก็คือว่าเอาไอ้เนื้อเทาเนี่ยนะครับน้ำสีเทามันซึ่งอาจจะเป็นประหลอดก็ได้นะครับพยายามให้มันอยู่ในเส้นเดียวกันนะให้มันอยู่0ตลอดอย่างเงี้ยตรงนี้เรียกว่า0นะสมมุติคุณเพิ่มลดอุณหภูมิแก๊สมันจะขยายตัวยังไงก็ตามนะครับคุณพยายามถ้าแก๊สมันขยายตัวคุณต้องเอาอะไรดีเอาขึ้นครับเอาขึ้นนะเพื่อว่าให้แก๊สมันชี้ที่0ให้น้ำระดับน้ำสีเทาชี้ที่0เหมือนเดิมนะเพราะตรงนี้มันดันมากเราก็ต้องยกนี้ขึ้นให้มันดันสูงขึ้นไปด้วยนะครับหรือว่าเอาลงนะผมว่าเอาลงนะใช่ป่ะน่าจะเอาลงสิพอเอาลงปุ๊บมันก็จะดันนะพอคุณให้พลังงานครับแรงดันมันตรงนี้มันสูงนะเราก็ต้องเอาลงครับพอคุณหยุดให้พลังงานไม่ให้ความร้อนมันตรงนี้พลังงานจะต่ำความดันก็จะต่ำด้วยใช่ป่ะเราก็ต้องยกขึ้นเพื่อให้ตัวระดับน้ำมันชี้ที่0ตลอดเวลาโอเค this is another constant volume gas thermometer okay it's not the the thermometer like this. Okay, the thermometer that use the liquid property expansion is the thermometer that we use. You may find in hospital or in any health center, right? Even in COVID or pandemic situation, you have to see the thermometer, right? And yeah, with this principle, the actual constant volume gas thermometer can be found in a realistic situation like this. Okay, and here is the place that we keep the air. Okay, so that we can observe the temperature. All right, here is what we have already discussed about is absolute zero. Let's talk about the temperature scale that can happen, that exists in nature. You know that the lowest temperature of anything could be zero, right? But what they found is something very, very close to zero, which is 10 raised to negative 10. And let's consider somehow like 2 Kelvin. We have helium. Helium is usually a gas, right? It's an inert gas. And at this situation, at 2 Kelvin, 2 degrees of Kelvin, the helium changes its phase from gas to liquid already at this level. All right, and if you go further at around 20 Kelvin, the hydrogen, hydrogen, right? H2, usually H2 or hydrogen is a gas, right? And it has only gas phase, but at this position, at this temperature, the hydrogen changes its phase from the gas to be liquid. Okay, let's consider another type of gas, which is nitrogen. Nitrogen will be in liquid form at somehow like 70 degrees of Fahrenheit of Kelvin, and of course for us it's 273.15, right? The water changes its phase from the liquid to the solid one. This is the freezing point. And copper, right? Copper is used as the conductor, right? In many other stuff like device for eating and so on, right? Cuisine stuff and so on. Copper is used for that application. But if you are at 1000 Kelvin, what is that? It's around 700 blah 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 degrees of Celsius. Okay, 700 Celsius degrees of Celsius. That's the melting point of copper. Copper will change its metal phase to liquid phase. All right. But if you are interested more, okay, above 700 Kelvin, we would have here around 6,000, 5,000, 6,000 Kelvin, which is again around 5,000 or 6,000 degrees of Celsius. You are at the surface of the sun, okay, because it's very, very hot, 6,000. I think everything is gonna be burned at that position because คุณรู้ใช่ไหมครับว่าขออภัยนะไม่ทราบว่าคุณศาสนาอะไรนะแต่ว่าเท่าที่ผมดูข่าวนะครับเตาเผาวัดนะครับเตาเผาวัดเนี่ยคุณรู้ไหมเขาใช้อุณหภูมิเผาเท่าไหร่มีโควิดคนเสียชีวิตเยอะเขาใช้อุณหภูมิเผาเท่าไหร่คุณทราบไหมฮัลโหลทุกคนอยู่ไหมครับรู้ไหมว่าเผาศพโควิดวัดบางวัดนะวัดที่เขาแบบสนใจสภาพสิ่งแวดล้อมเขาเผาศพที่อุณหภูมิเท่าไหร่ทำไมว่าเผาแบบสนใจสิ่งแวดล้อมก็คือเผาแบบไม่ให้มีเขม่าไม่ให้มีควันแบบให้ออกมาใสกิ๊บเลยครับ โดยเฉพาะวัดที่อยู่ในกรุงเทพมหานครนะเพราะว่าเผาเป็นดำปืดๆแล้วมันไม่ได้นะเพราะมันไปตกใส่เสื้อผ้าคนตากคนใช้ชีวิตอยู่อากาศหายใจนะครับในสิ่งบริเวณรอบๆนะดังนั้นวัดที่เผาศพก็จะต้องเผาแบบไม่ให้มีเขม่าเลยนะครับคุณรู้ไหมเขาเผาที่อุณหภูมิเท่าไหร่ทราบไหมครับมีใครเปิดไมค์ตอบได้ไหมพิมพ์ใครอยู่ YouTube พิมพ์ก็ได้นะโอเคไหมเขาเผาที่อุณหภูมิประมาณ 1,000 องศาครับโอเคไหมซึ่งอันนั้นเป็นอุณหภูมิที่สูงมากเลยนะมันหลอมเหล็กให้แบบละลายได้เลยนะครับเพื่อให้ไม่ให้มีเขม่านะครับให้ควันออกจากปล่องควันตรงเมนนะครับใสกริบเลยอ่ะเขาต้องเผาที่อุณหภูมิ 1,000 นะครับแล้วค่าดูแลใช้จ่ายสูงมากนะครับโดยเฉพาะอุปกรณ์ที่เตาเผานะครับตัวปูนของตัวเมนเองก็แตกร้าวนะครับโอเคมากแล้วคุณนึกดูนะครับที่ผิวของดวงอาทิตย์เนี่ย surface of the sun we are at 5,000 6,000 degree of Celsius or degree of Kelvin there is no difference at all when we are talking about several thousand of degrees of temperature all right yeah you know that it's very extremely high, much higher than the temperature that we use to burn the body of people from the pandemic situation. All right, and you may ask me, how could the physicists or the scientists say the surface of the sun has a temperature of 5 or 6,000 degrees of Kelvin?You may ask me the reason นะคุณทราบไหมว่าทำไมนักฟิสิกส์หรือว่านักวิทยาศาสตร์บอกว่าที่ผิวของดวงอาทิตย์มันประมาณ 5,000-6,000 องศามั่วหรือเปล่านั่งมโนหรือว่าเขานั่งยานอวกาศไปวัดอุณหภูมิเอาเทอร์โมมิเตอร์ไปจิ้มอยู่ตรงนั้นหรือเปล่าหรือว่าไง What is the reason behind that ไม่ใช่แบบว่าเรียนแล้วก็สอบจบอะไรนะทำดูในเอกสารประกอบการเรียนของอาจารย์ไม่ต้องทำอะไรมากวิธีทำก็ชัดเจนตรงๆก็สอบจบผ่านวิชานี้นะไม่ใช่อย่างแค่นั้นนะคุณต้องอยู่ในตามสภาพความเป็นจริงนะผมไม่ได้สอนแมทนะครับเข้าใจไหมแมทมันไม่ค่อยเกี่ยวข้องกับโลกความเป็นจริงแต่ว่าฟิสิกส์มันคือวิทยาศาสตร์อ่ะมันคือแบบมนุษย์พยายามทราบสิ่งที่มีอยู่รอบตัวนะครับในธรรมชาตินะครับเห็นไหม so what is the reason why scientists or physicists could say the surface of the sun is at the temperature of 5 or 6,000 by which sense because they use the light emitted from the suns to predict the temperature the scientists use the photon or the light spectrum to determine the temperature of anything because we would not have enough money to build up the spacecraft to reach the surface of the sun what we could do is to build up a very very giant the big telescope to observe anything around the earth or in the deep space and in solar corona in some area in the space they have temperature around 1 million Kelvin โอ้ไม่ต้องพูดถึงครับถ้าเป็นล้านนี่มนุษย์ไปไม่หลงเหลือครับเป็นเผาเกลี้ยงหมดครับโอเคไหม and inside the sun inside the sun the interior of the sun we have 10 million degrees of Kelvin it's extremely hard and hydrogen bomb which is a kind of process that could happen in deep space actually it's kind of nuclear fusion effect right nuclear fusion process right yeah the temperature of this process is 200 million degrees of Celsius you can see that this is impossible for the scientists which is also as same as they are also human they could observe this. Okay, we could not build up any thermometer that can support 100 million degrees of Kelvin. Okay, the scientists just used the light spectrum that could be observed from the telescope on any spatial device. Okay, and they convert the color of that spectrum to the temperature somehow. Okay, if you want to see the detail, you just study in the faculty of science, or you just browse it from internet. You don't have to attend the faculty of science. You can go ahead with your future. If you want to become a doctor, just go ahead with doctor. And if you want to see how the scientists interpret the light spectrum as the temperature, you just find a special reading or book about that. Okay, I'm not from the faculty of science. I don't know the method how the physicists or the scientists convert the light spectrum to be the temperature scale. All right, let's move to the next thing. If we compare all those three temperature scales, Celsius, Fahrenheit, and Kelvin, you will see that freezing point of water is 0, and on Fahrenheit is 32, and on Kelvin it's 273.15. The steaming point or the vaporizing point of the water is 100 degrees of Celsius, 212 degrees of Fahrenheit, 333.15 degrees of Kelvin. Okay, and normal temperature is 35, right? In Fahrenheit, we would say 98.6 degrees of Fahrenheit. Okay, if you wanna do the PhD, if you want to study the doctoral degree in the United States, okay, the people use Fahrenheit scale. You have to remember this number 98.6, okay, which is your body, your normal temperature for the normal temperature for your body. Okay, and on the Kelvin scale is gonna be 310.15. All right, and anything else? Oxygen will be in liquid form in 90 degrees of Kelvin, minus 195 degrees of Celsius, and minus 298 degrees of Fahrenheit. And carbon dioxide changes its phase from gas to be solid at 195 degrees of Kelvin, and negative 78 degrees of Celsius, and negative 109 degrees of Fahrenheit. Okay, and yeah, these two points are already discussed. Okay, now we arrive at the main the main interest for us is the conversion of temperature scale. As you know, we have three temperature scale before, right? Celsius, Fahrenheit, and Kelvin. If you want to convert the temperature from Celsius to Fahrenheit, you have this formula. Temperature in Fahrenheit is 9/5, or temperature in Celsius plus 32. If you have Fahrenheit and you scale, you want to convert any temperature to Celsius, you have to use this formula. Its temperature in Celsius is equal to 5/9 of the difference between temperature in Fahrenheit minus 32, right? Celsius to Kelvin is quite straightforward. You just add 273.15. If you want to get Kelvin from Celsius, you just deduce or subtract the temperature in Kelvin by 273.15. All right, and Fahrenheit to Kelvin is equal to 5/9. Okay, 5/9 of temperature in Fahrenheit minus 32, and this is the value you get in Celsius scale, right? But if you want to convert to Kelvin, you have to add 273.15 according to this formula. Okay, you combine these two formula together, you get this expression. And if you want to get Kelvin from the Fahrenheit, you have to convert first the Fahrenheit to Celsius like this. Okay, and you convert the Celsius to Kelvin by using this formula. Okay, you combine these two formulas together. Okay, substitute this one into this one. You get the Kelvin to Fahrenheit. Okay, that's the whole theory. Okay, you can choose any way the combination. It depends on the input and output, what you want to get at the outcome. And yeah, the way to get the temperature difference is like this. Okay, the temperature difference between Fahrenheit and temperature difference in Celsius is somehow like this. Let's consider room temperature. If we define as 25, okay, unlike the former one, they say 20 degrees of Celsius as room temperature. Okay, it's in the milder situation, the situation that we could live well, it's 25 degrees of Celsius. And yeah, this could be possible if you turn on your air conditioner in Thailand. Yeah, find the room temperature in degrees of Fahrenheit, find the room temperature in Kelvin. ไม่รู้นะครับอันนั้นคือใครครับโอเคyeah 25 right มีใครจะทำไหมไม่มีนะครับถ้าปกติห้องจริงผมจะเรียกให้มาทำนะตรงนี้ทุกคนทำได้ไม่ยากนะครับน่าจะเป็นกันตั้งแต่ชั้นม.ต้นแล้วด้วยซ้ำนะครับโอเค anyway it's my task to show you how to do that right we want to get room temperature in Fahrenheit scale and we have to say it's 9 by 5, right? 9 by 5 temperature in Celsius, right? In I think it's plus 32, right? Yeah, 9 by 5 plus 32. Okay, and you leave it the 25, right? 9 by 5 of 25 plus 32, it's equal to 45 plus 32, right? It's gonna be 77 degrees of Fahrenheit. All right, that's the first equation. Okay, the first solution for this problem. And the temperature in Kelvin, right? Temperature in Kelvin is quite easy. You have TK, and if you have TC, you have to add it by 273.15. Okay, in this case, we get 25 plus 273 จริงๆคุณเอาแค่273ใช้ก็ได้ไม่ต้องเอาบ้าจี้เหมือนผมครับ 273.15 นะครับ so it's going to be 298.35 degrees of Kelvin. All right, and that's it for this example. All right, yeah, we arrive at next example, but this will involve some special vocabularies. The temperature gradient between the skin and the air is regulated by the cutaneous blood flow. Sorry. โอเคก็คือเขาบอกว่าการเปลี่ยนแปลงอุณหภูมินะครับระหว่างผิวหนังและอากาศภายนอกนะครับของคนนะครับถูกควบคุมโดยเส้นเลือดฝอยที่ผิวเราสิมันเรียนอะไรนะเรียนฟิสิกส์จะไปเกี่ยวข้องกับชีวะได้ด้วยนะครับโอเคไหมครับประมาณนั้นเส้นเลือดฝอยนะครับเป็นสิ่งที่อุปกรณ์คือร่างกายมนุษย์เนี่ยโหมันสุดยอดมากนะครับมันสามารถปรับอุณหภูมิตัวเราโดยการปล่อยเลือดไหลไปตามเส้นเลือดฝอยเจ๋งไหมล่ะเยี่ยมไหมครับif the cutaneous blood vessels are constricted the skin temperature and the temperature of the event will be about the same โอเคก็คือสมมติคุณไปที่หนาวๆครับถ้าเส้นเลือดฝอยมันหดตัวไม่ยอมให้เลือดมันไหลนะครับไม่ให้ยอมให้เลือดมันไหลตามผิวพอไม่มีการเอาของอุ่นไปวิ่งรอบตัวคุณนะครับแขนของเราจะเย็นมากใช่ไหมแขนของเราเนี่ยจะเท่ากับอุณหภูมิข้างนอกเลยนะครับก็คือ เริ่มมีปัญหาแล้วนะครับเส้นเลือดฝอยหดตัวนะครับไม่ยอมให้เลือดไหลนะครับเลือดไหลก็คือรักษาอุณหภูมิร่างกายนะครับ when the vessel are dilated more blood is brought to the surface โอเคเมื่อเส้นเลือดมันขยายปุ๊บเลือดมันก็จะวิ่งไปทั่วตามผิวหนังเราก็จะเป็นไงครับไม่ใช่เลือดฝาดเลือดแดงแก้มแดงนะหมายถึงว่าตัวเราก็จะอุ่นขึ้นอุณหภูมิสูงขึ้นโอเคไหมอันนั้นคืออัจฉริยะของมนุษย์นะคือเรียนวิศวะเนี่ยนะครับณปัจจุบันนี้นะคุณจะคิดอัลกอริทึมอะไรก็ได้นะให้มันฉลาดเท่าระบบปฏิบัติการของร่างกายมนุษย์เนี่ยที่มันสู้เชื้อโรคได้เนี่ยคือว่าถือว่าเก่งมากเลยนะครับมีระบบนิวรอนคือแบบมีส่วนควบคุมได้สุดยอดมากอะร่างกายมนุษย์นะครับณปัจจุบันวิศวกรรมยังไปไม่ถึงนะครับผมพูดได้ประมาณนี้นะยังฉลาดไม่สู้ร่างกายมนุษย์นะครับเนี่ยแค่ระบบปรับอุณหภูมิร่างกายตัวเองโอ้โหยังอัตโนมัติได้ขนาดนี้นะครับดังนั้นรักษาสุขภาพร่างกายคุณให้ดีๆนะครับเห็นไหมมันเป็นระบบที่ชาญฉลาดมากเลยนะครับอย่าให้พังเสียหายนะครับเก็บไว้ใช้เอาไว้สร้างให้คุณเจริญงอกงามไปข้างหน้าในอนาคตนะครับ Suppose during duration of the skin warms 72 degrees of Fahrenheit to 84นะเริ่มมีการกระจายเลือดเข้าไปในร่างกายแล้วนะครับทำให้อุณหภูมิคุณสูงขึ้นจาก72ฟาเรนไฮต์ถึง84ฟาเรนไฮต์คือมันพูดรู้เรื่องอะถ้าคุณอยู่ในอเมริกาอยู่ในเตสตีดอะโอเคไหมมันรู้เรื่องอะแต่เรามันไม่ได้อยู่อเมริกาคุณพูดมาฟาเรนไฮต์แล้วใครคนก็จะคุณไปฉีดวัคซีนแล้วคุณบอกอุณหภูมิคุณอยู่ในหน่วยเคลวินอย่างเงี้ยคุณหมอคุณพยาบาลคุณแพทย์นี่งงตึงนะครับโอเคไหมเขาไม่ค่อยใช้เคลวินกันโอเคไหมครับเขาใช้แต่ degree of Celsius นะครับหรือคุณจะไปพูดฟาเรนไฮต์กับคุณหมอที่ประเทศไทยนี่ก็คุณพยาบาลหรือคนเจ้าหน้าที่ก็จะงงตึงเหมือนกันดังนั้นเปลี่ยนหน่วยให้เขาเสียก่อนนะครับโอเคไหม so let's consider the first problem convert these temperatures to Celsius and find the difference and convert the temperature to Kelvin again find the difference okay yeah we want to convert the temperature from Fahrenheit scale, right, to the Celsius scale, right? And one thing I forgot to mention, the Kelvin scale. Okay, the Kelvin scale doesn't require the small circle at all. Okay, K has no small circle. You can see here, Fahrenheit has degree. Celsius has degree symbol, which is small circle, but Kelvin doesn't have. Okay, doesn't need degrees at all. What is the reason behind that? Because Kelvin scale is the absolute scale. Okay, no other matter substance can reach the negative 273.15. Okay, so we don't write down the degrees or the small circle anymore for Kelvin scale. All right, that's the typical way. อยากเขียนวงกลมมานะเขียนวงกลมมาเสลอเลยนะครับเขียนมา so the next question is convert the temperature from Fahrenheit to Kelvin. So it's not difficult in this case whenever you are able to convert the temperature to Celsius. All right, so let's consider the next thing. When the okay we first consider the temperature at 72 degree degrees of Fahrenheit, right? And the second one, no, we'll say it later. The second one, okay, at the 32 Fahrenheit, if you want to convert it to degrees of Celsius, okay, it's possible. You just say Tc is equal to it's 5/9, right? 5/9 and Tf minus 32, right? Yeah, and we have to substitute right now 5/9 and what is that? 72 minus 32 is gonna be 5/9 of 40. Okay, and you have to multiply this, and it's gonna be 200/9. Okay, and we use the calculator. 200/9. Okay, it's equal to 22.22. Okay, it's around 22.22 degrees of Celsius. Huh? Is that all right? I'm not sure. ใช่เหรอ 72 to 22 72 Fahrenheit to Celsius. Yes, it's all right. It's correct. Okay, and what about this temperature in Kelvin? So TK is gonna be TC, right? Plus 273.15, and it's going to be 22.22 plus 273.15. I think we are running out of time. 295.37 Kelvin. Okay, and here is the degrees of Celsius, and in the second state, at the temperature of 84 Fahrenheit, we can get TC from this expression. 5/9 of TF minus 32. 32, yes, and 5/9, and TF is 84 minus 32. You get 5/9 of 52, right? And it's gonna be 260/9. It's equal to นะครับแต่เริ่มต้นนะครับอุณหภูมิควร22 องศานะซึ่งถือว่าค่อนข้างต่ำนะครับโอเคไหมต่ำ and 260 is gonna be 28. Okay, 28.89 degrees of Celsius. โอเคเพิ่มเยอะโอเคครับจาก22มา28เกือบ29 องศานะครับเพิ่มครับเส้นเลือดปล่อยเลือดเลี้ยงไปตามเส้นเลือดฝอยนะครับร่างกายจัดการ so we're gonna find the third thing. Okay, the delta temperature in what is that, in Celsius and in Kelvin, right? TC, delta TC, what is that, right? And delta TK, what is that, right? So what is delta TC? Delta TC is gonna be what is that? Oh, I forget to say T Kelvin in this situation. T Kelvin is gonna be TC plus 273.15, right? Which is 28.89 plus 273.15, right? And here is gonna be it's going to be 4,9, right? 0 and 1, right? And 9, 301.91. Yes, and it's in Kelvin, right? In the second state. Okay, delta TC is going to be 28.89 minus 22.22, right? Yes, 0.22. It's going to be 6.67 and degree of Celsius. And for the delta TK, difference of temperature in Kelvin scale is going to be the same thing actually. So 301.04 minus 295.37, and you would get 7 and 6 and 6 again. Okay, you can see that the difference of temperature, whether in degrees of Celsius or Kelvin, will be the same. Okay, 6.67. Now we reach the final example. Normal internal body for human is 98.6. Find the temperature in degrees of Celsius and in Kelvin. And the first situation first. Okay. In the first situation, we have 98.6 degrees of Fahrenheit. And we want to find the temperature in Celsius. TC is, how could we find that? It's 5 by 9, right? 5 by 9 of TF minus 32. And you get 5 by 9 of 98.6 minus 32. And it's going to be 5 by 9 of 6.6 and 6. Okay, 3 times of, oh no, 5. Yeah, 6. Yeah, 6, 3 times of number 6, and you would get, I think, 37 degrees of Celsius, I think. Right? And let me check it again, otherwise you get something wrong, and that's why that will be my mistake. 5 by 9 times 66.6. It's 37 exactly. Yeah, here. Okay, the value in degree of Celsius, and the temperature in Kelvin is gonna be 273.15 plus TC, okay, which is 273.15 plus 37, and it's gonna be 310.15 degree of Kelvin. Okay, and that's it. Let's consider the second situation. They say when human is relaxing on a couch. Okay, if you sit down on a couch, your body is clever, okay? It's intelligent. The skin temperature is reduced, okay? They will not let the blood flow around your body, okay? And then your body is gonna be cooler, okay? And the cooler amount is 2 degrees Celsius reduction, and than the internal temperature. And how much lower is the skin temperature in Fahrenheit degrees and in Celsius? Okay, you have the change of temperature by in the second situation, you have the difference of temperature in Celsius by 2, right? By 2 degrees of Celsius, and you want to convert it to Fahrenheit, right? So you have to use this expression, this one, no, this one, okay? Delta TF is 9 by 5 of delta TC, okay? Delta TF is 9 by 5 delta TC. So we use this one. We use that expression. Delta TF is 9 by 5 delta TZ. So you have difference as number 2, right? So you just multiply it, and is what is that? It's 19 by 5, right? 19 by 5. It's going to be 3.6 degrees of Fahrenheit. All right, and that's it. And if you consider the difference of the temperature in Kelvin scale, delta TK is going to be exactly the same as delta TC, okay, which is 2 degree of Kelvin. Okay, all right, we complete all of this stuff. We are running out of time 6 minutes later. โอเคนะครับวันนี้ก็จบเรื่องเกี่ยวกับการเปลี่ยนหน่วยของอุณหภูมินะครับก็เริ่มต้นของวันนี้เหรอครับก็กล่าวเกี่ยวกับเรื่องยูนิตอุณหภูมินะครับที่หน่วยของอุณหภูมินะเริ่มจากเซลเซียสเลยนะครับโอเคไหมเริ่มจากอันเดอร์เซลเซียสนะครับก็คือหน่วยเซลเซียสนะครับแล้วก็ว่ากันไปนะครับใช้ทั่วโลกนะครับแล้วก็ฟาเรนไฮต์นะครับใช้โดยเฉพาะประเทศสหรัฐอเมริกาแล้วก็ประเทศที่ใช้ภาษาอังกฤษหลักนะครับเขียนพวกอาจจะแอฟริกาใต้ด้วยอะไรอย่างนี้นะครับผมก็ไม่เคยไปนะครับก็พูดถึงสเกลนะครับวัดจากจุดแข็งตัวของน้ำแล้วก็จุดเดือดของน้ำนะครับแล้วก็มาอุณหภูมิที่นักวิทยาศาสตร์ใช้ไม่ใช่แค่ในห้องทดลองครับอันนี้มันจะเน้นไปเกี่ยวกับสสารที่อยู่นอกโลกด้วยนะครับเขียนว่าอุณหภูมิแบบสุดขั้วจริงๆนะครับนั่นคือเปลี่ยนสถานะกันสุดๆนะครับนั่นคือเคลวินนะครับก็เป็นยุคใหม่ของหน่วยอุณหภูมินะครับก็มีสูตรในการเคลวินหามาได้จากการที่นักวิทยาศาสตร์วัดแก๊สนะครับแล้วก็คิดว่ามันน่าจะโปรเจกต์ไปยังค่าหนึ่งนะครับนั่นแหละก็ไม่แน่นะคุณอาจจะเป็นนักวิทยาศาสตร์ยุคใหม่นะอาจจะค้นพบสิ่งใหม่ๆนะครับเพราะว่ายังไงผมก็เป็นคนรุ่นเก่าไปแล้วนะก็หวังได้แต่พลังงานความสามารถคุณนะครับก็สเกลต่างๆของอุณหภูมินะครับที่อยู่ในวิชาฟิสิกส์นะครับในที่เราสามารถมนุษย์สังเกตได้นอกโลกนะครับตั้งแต่ไฮโดรเจนบอมปฏิกิริยานิวเคลียร์ฟิวชันนะครับแล้วก็ภายในเลยนะของดวงอาทิตย์นะครับจะประมาณ10 ล้านอันนี้100 ล้านนะครับปฏิกิริยานิวเคลียร์ฟิวชันแล้วก็ตัววงแหวนโซล่านะครับรอบๆดวงอาทิตย์ก็จะประมาณ1 ล้านนะครับแล้วก็ที่ผิวโซล่าโคโรนาก็คือวงแหวนของระบบสุริยะนะครับแล้วก็เซอร์เฟซผิวของดวงอาทิตย์ก็จะประมาณสัก 5-6 พันนะแล้วก็นะครับอันนี้จะเป็นในโลกแล้วนะครับจุดหลอมเหลวของทองแดงแข็งจุดแข็งน้ำอะไรพวกนี้นะครับเป็นในโลกหมดแล้วนะครับแล้วก็อุณหภูมิสเกลต่างๆจะเห็นว่าพิชหรือว่าความถี่ของบาร์ของแถบนะครับบนฟาเรนไฮต์ก็จะแน่นกว่าของพวกเคลวินและก็เซลเซียสนะครับแล้วก็สเกลต่อสเกลนะครับจุดเดียวกันนะครับอุณหภูมิห้องอุณหภูมิร่างกายมนุษย์นะครับก็จะมีนะครับเป็นค่าไปนะครับแล้วเราก็มาถึงสสารพวกแก๊สนะครับเปลี่ยนเป็นของแข็งออกซิเจนเปลี่ยนเป็นของเหลวอะไรอย่างเงี้ยนะครับหรือว่าเก็บอะไรนะวัคซีนไฟเซอร์ก็-70 องศาอะไรอย่างเงี้ยนะครับแล้วมาถึงเรื่องการเปลี่ยนแปลงอุณหภูมินะครับจากสเกลหนึ่งไปสเกลหนึ่งก็มีสูตรต่างๆให้ดังนี้นะครับแล้วผมก็พาหาการดูตัวอย่างนะครับ3ตัวอย่างนะในการเปลี่ยนอุณหภูมิให้ดูนะครับโอเคไหมก็ทำให้ตรงนี้แล้วเดี๋ยว convert ไฟล์ส่งให้นะใครยังไม่ได้เขียนชื่อโปรดเขียนชื่อนะครับso we are gonna finish our lecture right now. It's noon. Okay, see you on next Thursday, right? สวัสดีครับบ๊ายบายครับ No one is gonna be there. Okay, only นนทกรสวัสดีครับบ๊ายบายครับ Meeting fast. Oh.